Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ukobela Met. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5. It says, after an emergency landing at Bloemfontein Airport, a passenger of mass 700 kg evacuates the stationary aeroplane using the evacuation slides that makes an angle of 40 degrees with the horizontal. When the passenger reaches a height of 2.8 meters above the ground, the passenger has a speed of 0.35 meters per second. So now we can see that the whole action here starts when the passenger is now at a height of 2.8 meters. So we should consider this to be our initial point or our starting point. Then 5.1 says, define the term non-conservative force. And how do we define that one? We say the non-conservative force is a force for which the work done in moving an object between 2 points depends on the path taken. Right, and that's how we are supposed to define non-conservative force for 2 marks. Right, and then let's proceed. We are told that a constant frictional force acts on the passenger as it moves down the incline. 5.2 says, draw a label free body diagram showing all the forces exerted on the passenger. Okay, so now the first thing that you want to do is you just faintly draw your incline, which you will then erase after. So you're just drawing it so that you can correctly draw all your forces there. So we have first the normal force. So let's do this. We have our normal force that will be going up there. And then we have our FG perpendicular. Then we will have our FG parallel. Then up here, we will have our frictional force. Then this is 3 marks. That means we have 3 forces. Remember, when it comes to FG parallel and then FG perpendicular, we say these are components of the same force, which is gravitational force. So when we mark these ones, we mark them as 1. So that's FG parallel. And here we have our FG perpendicular. Then this is a kinetic frictional force. And then up here we have our normal force. So this is our free body diagram. And then how is it going to be marked? It's 1, 2, and then 3. Right. And then you can also draw the other one if you prefer that one, whereby you just go, this is the normal force, and then this is your kinetic frictional force. Then just straight like this, horizontally downward, this will be your gravitational force. So either one of these free body diagrams is correct, right? So whether you prefer this one or you prefer the resolved one. But then in terms of preference, I prefer the one that is resolved, because when it comes to calculation, you can clearly see all the horizontal forces that you will need to use there. Okay, then 5.3 says, name a non-conservative force acting on the passenger. So remember, the non-conservative forces that we have are either kinetic frictional force, applied force, or tension force. Then we do not see any applied force or tension. That means the only non-conservative force that we can observe here is definitely the kinetic frictional force. So kinetic frictional force. That's a non-conservative force that's there. Okay, then we are done with this one. We can see easy peasy. We've been given 6 marks just for free there. Right. Then let's now go. The coefficient of kinetic friction of the surface is 0.112. Now, I always made you note that every time we are given the coefficient of kinetic friction, then we know the next step is to calculate the kinetic friction. So we are given the coefficient, so you need to calculate the coefficient of kinetic friction. If you can just allow me to go back to this here, we can see that from our free body diagram, this is Fn is equals to Fg perpendicular. But why am I making you look at this? It's because when we want to calculate our kinetic frictional force, we say Fk is equals to mu k multiplied by n, right? So what is our mu k? That's 0.112. That's our coefficient. But then our normal force must be equal to the Fg perpendicular. So we can replace normal force by Fg perpendicular, as we know that our vertical forces always balance each other out. So our vertical forces are always equal. So to find the normal force on an incline, we have to equate it to the Fg perpendicular. Then this is 0.112. This breaks down to mg cos theta. And then this is 0.112. multiplied by the mass is 70, then times 9.8, then that's cos 40 degrees, right? So we can see the 40 from here. Then when we are doing that, multiplying that will give us a value of 58.86 newtons, right? Okay, then now let's proceed and calculate So now that we have that, we can say this is our Fk. And then since we have Fk, we can use the work done by the non-conservative force, since we know that kinetic frictional force is a non-conservative force. Then this goes as change in P plus change in K. Right. So remember, we are using energy principle, and then this is an energy principle. Right. So let's break down our work done by non-conservative force. This is represented by the work done by Fk. So to break it down, we would end up having Fk delta x, then cos theta. That's equals to mg, height finally minus height initially, plus half. And then that's mvf squared minus vi squared. Right. Now already we have our value for Fk, but then our problem is, what is delta x? We are not shown delta x there. It is not indicated in our diagram. Therefore, we have a problem. But then how can we solve that problem? If you can look at this forms a right angle triangle. And then our displacement, we know that it is always the hypotenuse here. So that means using our SOHCAHTOA, our trig ratios, we can actually calculate the value of delta x there, because we do have the angle and then we do have the height, which is our opposite side to the angle there. So let's use that in order to calculate. So this will be sine 40 degrees, and then is equals to opposite. If we are using the trig ratio sign, that's opposite of our hypotenuse. Our opposite is 2.8, and then our hypotenuse is delta x, meaning that if we want delta x, we can simply say 2.8 over sine 40 degrees, right? Then our delta x, if you punch all that into your calculator, becomes 4.36 meters, right? So now we have found the delta x and we've also found Fk. All we have to do now is just substitute into the formula there. Then our Fk is 58.86 multiplied by delta x, which is 4.36, and then cos 180 degrees, right? Then this is equal to, so let me just say equal to here. So note that this is on the left hand side, and all that I'm going to write here will be on the right hand side. So I hope you follow. Then this is the mass is 70, then multiplied by 9.8. Our height finally at this point will be 0, but then the height initially at that initial point is 2.8, and then plus half, mass is still 70. Our VF squared, that's what we are looking for, because it says use energy principle to calculate the velocity of the passenger at the lowest point. At the lowest point, that's your V final. Then VF squared. But then initially we've been told that the passenger has a speed of 0.35. So our V initial is 0.35 and then square. Right. Then punching all this into your calculator, the one on the left-hand side, we're going to have negative 256.62 0.96, so I'm not rounding off any values. Then if we punch this, 70 times 9.8 multiplied by 0 minus 2.8, that's a negative 1920.8. Then plus, if we say half of 70, that's 35, multiplied by VF squared, that's 35 VF squared. And then again, 35 multiplied by negative 0.35 square, that's going to give us negative 4.2875, right? Then at this point, we are supposed to take all of this over to the left-hand side. So transpose all of that over to the left-hand side. Then if we do that, we're going to end up with 1668.4579. Then we are only left with the 35 VF squared to this side. Then we can divide both sides by this 35. Then that's VF squared is equals to 47.67 and a whole lot of decimals there. So I'm not going to round off any. I'm just going to punch in my calculator, square root answer. Then my VF is equals to 6.90 meter per second, right? And that's the velocity at the lowest point. That's how you were supposed to calculate that. So make sure you follow through with how I calculated this, the method that I used, and then just make sure that you practice this and until you understand. Okay, so 5.5 says the angle between the horizontal and the slide is increased. How will the change influence the frictional force acting on the passage? So, okay, let's clear the screen for that one. So this is 3 marks. We are supposed to explain what will happen if the angle is increased. So suppose that we are increasing the angle to, let's say, 60 degrees, right? Now we want to know what will happen to the frictional force, right? To the magnitude of the frictional force. Will the magnitude of the frictional force increase, decrease, or remain the same? Now, if you can think of this, let's say now we are to place an object here and let it slide at its own accord. Now you do understand that if it's sliding at an angle of 40 degrees versus when it's sliding at an angle of 60 degrees, logically so we know that here it is bound to be much faster because of the angle here. It's much more steep. So this will cause that free falling motion. I don't want to say free falling because that's something else, but then just that slide there, it will cause it to slide much quicker than when the angle is low, right? So now, how do we this in terms of scientific terms? So at this point, we do understand why is it sliding faster when the angle is increased. It's because it experiences a lower frictional force. So what we can say about that is that the frictional force decreases, right? But then why? This is how we are going to explain it. I want to say according to the formula, which is Fk is equals to mu k times n, we know that Fk will be directly proportional to the normal force for a constant mu k, right? So if we keep our coefficient of friction constant, because remember the coefficient of friction cannot be changed by changing the slope of the surface, right, or the slide. So this one will still remain constant. So Fk is directly proportional to normal force for a constant coefficient of friction. Then we know that increasing the angle of the slide actually decreases the magnitude of the normal force, decreases the normal force. So it decreases the normal force, right? Now, if this decreases the normal force, that means since we said that Fk is directly proportional to the normal force, that means if the normal force decreases, also the Fk decreases. So it decreases the normal force and therefore also decreasing the frictional force. Frictional force. So I guess it would be 1 mark for just explaining that, then maybe 1 mark for explaining the relationship there and also backing the relationship, right? So according to the formula, Fk is equal to mu k, and Fk is directly proportional to the normal force for a constant mu k. Increasing the angle of the slide decreases the normal force and therefore also decreasing the frictional force, right? And then that's how you were supposed to explain that for a total of 3 marks. And then the whole question was for a total of 15 marks. So that's it, guys. Make sure that you practice this topic. It's a very nice topic. Make sure that you know all the conditions for using the energy principles. So that being said, guys, please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.